Alright, so you have your outline for today's notes in front of you. Make sure your name is on your notes. And we're not going to be taking too many notes today. I'm just going to walk you through the basic steps because, as I said, this is really pretty basic. It just may take a few days to get used to it and to really get your head wrapped around what you're doing. Some of you will pick it up right away. Others of you, it's going to take a minute. And either way is fine, okay? Because there's no rush, but you are going to get it. And let's start off by talking about why we balance equations, just like we discussed in your warm-up. We need to be able to show the law of conservation of mass, that atoms are neither created nor destroyed. That's all that the written equation is showing you. When you're balancing an equation, you're showing that all the atoms that were on your reactant side of an equation are also in the product side. So you should be writing this down on the outline of your notes. That atoms cannot be created or destroyed. That all the atoms we start with, we're going to end up with in a chemical reaction. That matter is not going to disappear. And a balanced equation has the same number of elements on both sides of the equation. That's the actual showing or the representation that you have the same matter on both sides of your equation. Does anyone have a spare pencil? Anybody mind loaning Cheney a spare pencil, please? Thank you. So I'll repeat this one more time for those of you still writing. Atoms cannot be created or destroyed. All of the atoms that we start with in a chemical reaction, we're going to end up with. All of the reactants will be present in the product side. They will be rearranged, but they will be present. So therefore, a balanced equation is going to have the same number of elements on both sides of the equation. Now, the next slide, I'm going to go ahead and give you the steps to balancing an equation, and then we're going to get in depth with those a little bit more. But we're going to first start by just writing down the steps. So to balance chemical equations, the first thing you're going to do is write the correct chemical formulas for all the reactants and products. Write the correct chemical formulas for all the reactants and products. And many times you will already be provided with the equation. Secondly, you're going to count the number of atoms of each type appearing on both sides. So you'll count all of the individual elements represented on both sides of the equation, the reactant side and the product side. Then you're going to start with the most complex compound that you see and start balancing the elements one at a time by adding coefficients, which, remember, the coefficient is going to be a numerical value in front of the element symbol or in front of the formula that tells you how many molecules of that element or compound that you have. So there's an example there, 2C2O. CO2. And that coefficient of 2 just shows us that we have 2 molecules of carbon dioxide. And those are the only things you will ever write when you're balancing an equation, are coefficients. Step 4 is to check your work, because sometimes it's easy to make careless errors. And step 5 is to recheck your work. Especially when you start feeling confident, that's when the careless errors start to happen. Now, these steps don't mean much till you've tried putting them in action. And we're about to do that, but there's a few do's and don'ts. Here's some don'ts. Some things you're not going to do. You're never going to change a subscript to balance an equation. You're never going to change a subscript to balance an equation. What are you never going to do? Change a subscript. Because, for example, CO2, if we change that to CO4, is it the same compound? No. Because we got a different number of elements within that compound. Different ratios, so different substance. So you're never, ever, ever going to change a subscript. Another example would be H2O. That is a totally different substance, a totally different compound than H2O2. So you're never going to change a subscript. And the only other thing you're never going to do is put a coefficient in the middle of a formula. For instance, NaCl, which is sodium chloride or table salt, isn't the same thing if you put a coefficient or a number in the middle of that formula. If you break it up and put Na2Cl, that's a different substance. So you're never going to put a coefficient in the middle of a formula that's there. It will only be in front of a formula. So no subscripts, and you don't break up a formula. This is all going to start to make a little bit more sense when you actually put it into action. So here we go. Let's try that. And if you're not finished writing, do remember that these will be on my website. Okay. So here's an example. On the back side, it's got a spot for you to write an example. If you'll please write down this equation. We've got a diatomic molecule of hydrogen that we are adding to a diatomic molecule of oxygen. We're going to see how hydrogen and oxygen react. And this happens every day. Hydrogen and oxygen react to form water, H2O. Now, just looking at that equation, do you believe that this is an accurately balanced equation? Just looking at it. What do you think? Raise your hand if you think yes. No one. Okay. Would anybody like to tell me why you believe it's not balanced? Brennan?
Because the subscript of oxygen is being taken away.
Okay. He said the subscript of oxygen is taken away. So what does that mean then for your product?
There's one less atom.
There's one less atom of what?
Oxygen.
Of oxygen. So we don't have the same number of atoms on our reactant side that we do on our product side. So here's how we're going to balance. And you remember all the atom counting you did week before last? And you did very well, might I add. You are atom counting experts. This is where that skill is going to come in handy. So I would like you, there are several methods, but you are going to use a method where you show your work and make a chart. And it's called the tally method. So let me show you how to do that. You're going to make a table to keep track, and it looks kind of like this. Okay? Notice I have an R representing the reactant side of my equation and a P representing the product side. So if you'll copy this for me, you'll notice I have already counted my atoms on both sides. So on my reactant side, I have how many hydrogen? I can't hear you. 2, good. On my reactant side, I have how many oxygen? 2. And that yields water. How many hydrogens do I have in this molecule of water? 2. And Cheney, how many oxygen? 1. So this is where Brendan was saying we have 1 less oxygen. So this equation is not accurate. It's not accurately balanced. Okay? This is not how it works in real life. We have to have a balanced equation to represent the real reaction. So you've counted your atoms. The next thing you're going to do is add coefficients to make it right. So where might we add a coefficient to make this equation balanced? Which element do we know we need to fix? Oxygen, okay. And on which side of the equation? Product side. Okay, we want it to be 2. So how can we make oxygen on the product side 2? How can we make oxygen on the product side 2? What's the only thing you can add to balance an equation? Coefficient. Where can we put a coefficient on the product side? In the front. Can we put it in the middle? Can we put it behind? There's only one place we can put it. So we're going to do that. Okay? I did that. So notice I have a 2 now as a coefficient in front of the molecule of H2O. So once you add a coefficient, you're going to recount because you just changed how many atoms you have on that product side. So let's do that. And I call it the cross-out method. You do not want to erase when you're recounting because if you make a mistake, it is much harder to determine where you messed up if you've erased things. So just cross it out like this. Okay? I know that my coefficient of 2 applies to every element behind it. So I now have 2 oxygen and 4 hydrogen, because remember we learned as counting atoms, we multiply the coefficients and subscripts. And that subscript only applies to the hydrogen on the product side. So, did I balance my oxygen?
Yes.
Yes, I did. But what did I do? I totally threw off my hydrogen. That's okay. That happens. Now all we have to do is go back and adjust for that. So now I have 4 hydrogen on my product side. What do you think I can do to officially balance this equation and make sure I have the appropriate number of hydrogen on the reactant side? Because I worked out the oxygen, nice and tidy. Threw off the hydrogen. What do you think, Connor?
Add a coefficient in front of the H2.
He says, very good. He says to add a coefficient of 2 in front of the H2 on the reactant side. Raise your hand if you think that will work. Got about 60% of you that think so, and the other 40 aren't so sure. Okay? Well, let's try that. Let's do just what Connor said. I've added a coefficient of 2 in front of my hydrogen, my diatomic molecule of hydrogen. Now, let's recount. I added a coefficient. Let's recount using the cross-out method. How many hydrogen do I, or I'm sorry, how many oxygen, one at a time. How many hydrogen? Okay, I've multiplied. Okay, does that coefficient that Connor added, why doesn't that apply to the O2 on the reactant side? Why doesn't that apply? There's a plus sign. Remember, coefficients can't hop over plus signs. They're not that brave. Okay, so now that we've added that coefficient of 2 in front of the H2, do we have a balanced equation? We do. So that is the official formula that shows or demonstrates the chemical reaction between hydrogen and oxygen resulting in water molecules. This is what it looks like in every instance. Okay, so that is an accurately balanced equation. And that's really all there is to it. Now, they do get more difficult, okay? But we're going to start easy and keep practicing. And then by the end of this week, maybe early next week, you will be quite savvy in balancing chemical equations. So, what I'd like to do now is we are going to work together on balancing some equations. See if I can get my technology to work. And I'm going to have Cheney, will you do me a favor, dear? There are some sheets called Balancing Act up there. Will you make sure that everybody gets one of these? I'm going to see if I can't get this up over here. Somehow. Nope. Okay, let's try this. This might work. Yes. Oh, thank you. All right, so go ahead, put your name on it, because this is going to be very helpful later. And we're going to start by filling in some really important words that help us remember why we're doing this. See if you can help me out. Atoms are not blank or blank. Hold on. Atoms are not blank or blank during a chemical reaction. What do you think, Katie? Very good. Created, and grammatically this should be nor. Scientists know that there must be the blank number of atoms on blank of the blank. Think about that for a minute. I'm not a big fan of fill in the blank questions, but I bet you can figure this out. Scientists know that there must be the blank number of atoms on each blank of the blank. What do you think, CJ?
The same number of atoms on each side of the equation.
Very good. Scientists know that there must be the same number of atoms on each side of the equation. Very good. And to balance the chemical equation, you must add what and only what in front of the chemical formulas in this equation? What do you think, Mackenzie?
Coefficients.
Coefficients. Now, see if you can get this one. This one might trick you a little bit. You cannot blank or blank subscripts. What do you think, Alex?
Add or subtract.
Okay, that's a good guess. Hold on, don't write yet. He says add or subtract, and you're not entirely incorrect, or you're not incorrect. But there may be one more word. Well, you know what? Let's go ahead and write what he said. Let's write remove. You cannot add or remove subscripts. That's true. But what else? There should have been a third blank. What else can't you do? You can't add or remove subscripts. What else do you think you can't do with a subscript? What do you think, Connor?
Change it.
Change it. So if you've got a subscript of 2, you can't change it to a subscript of 3 to balance an equation. You're going to leave those subscripts alone. They didn't do anything to you. Change. Let's add it there. You're not going to add, you're not going to remove, and you're not going to change any subscripts. And I have the steps listed here for you again. Okay? So we'll make it a helpful cheat sheet later. So the first thing we're going to do, we already have the equation written, so we don't need to do that. This is Mg plus O2 yields MgO, magnesium oxide actually. And I have have little boxes there for you to fill in coefficients where needed. But just because there is a box does not necessarily mean you must put a coefficient in there. It's just there if you need it. So first, what are we going to do? What does step number 1 say? What does step number 1 say, Vanessa? Very good. Determine the number of atoms for each element. We are going to count our atoms. So let's do that. How many magnesium do I have? Good. How many oxygen? How many on my product side of magnesium do I have? Chip? Good. And how many oxygen? Cheney? 1. Just 1. So, very similar to our example from the PowerPoint, isn't it? Oxygen, not even. We've got 1 less oxygen over here. So what can we do to make sure it is balanced? What is the only thing we can add? Coefficients. We want our oxygen over here to match our oxygen over there. So what will we do? What do you think, Ben?
2.
Add a coefficient of 2 where?
To the product.
To the product side. Let's do that. And then once you've added a coefficient, you must recount because you've made a change. So once you've added that coefficient, we recount. All right, so let's go ahead and use we're going to do the tally method where we cross out, not erase. So now how many magnesium do we have? Hello, are you out there? Good. And how many oxygen? 2, because remember that coefficient applies to every element after it. Now, we did a lovely job of balancing out our oxygen, but we've thrown off our magnesium. So how can we balance our magnesium now on the reactant side, Justin?
You have to put a coefficient on magnesium.
On which side?
Reactant.
Correct, sir. You are going to put a coefficient of 2 on the reactant side before magnesium, and then you recount. So now how many magnesium do I have?
2.
Is this equation balanced? Yes, so the correct formula for magnesium oxide, if we were going to write that equation out without all the boxes, that's what it looks like. Okay? And that's really all there is to it. Now, these are fairly simple. They will get more challenging, but we're going to keep with simple. So what I'd like you to do now is just take a moment. There's 2 or 3 or 4 on this page. 4, there we go. There's 4 on this page. I want you to try. I'm going to do 1 more with you. Okay? And then I want you to try the other 3 on your own. And then we are going to go over each and every single one of them. Okay? But I'm going to do the next one with you, and then I'm going to let you try the remaining 3 on this page on your own. So how many calcium do we have in this example?
1.
We have 1. How many oxygen?
2.
2. Product side, how many calcium?
1.
And 1 oxygen. So it's exactly the same as the last one with different elements, isn't it? Okay, so we should have a pretty good idea of what to do. We've counted our atoms. We see that our calcium are balanced, our oxygen are not. We are 1 short on our product side. So I'm going to add a coefficient of what?
2.
2. And I'm going to recount. I now have 2 calcium and 2 oxygen, and just like in the last example, I've now thrown off my calcium count. So where do I need to put my next coefficient, David?
In front of the calcium on the reactant side.
Very good. In front of the calcium on the reactant side, I've made a change. I need to recount. So we've done 3 that were almost exactly the same. So let's try the next 3, which are not exactly the same, and then we're going to go over them as a group. So give those a try. First, if you ever blank on what you're supposed to do, just start by counting atoms.